Come on, Twitch. Well. Okay, now I'm streaming. Let's go tell the world about it. Streaming game dev. Gonna get back in the saddle while the wind blows. Pop on over here. Here. There we are. So, what we have this week is it's been a long time since I actually worked on this project because I took a week off for doing that jam that I did. And the other, I took a day off because Unity's license stopped working and I had to go to extraordinary lengths so that it would let me log in. Like, I couldn't even open Unity. It was borked so bad. And in theory, it was because Microsoft updated something, and for some reason, Unity interpreted that as you are now trying to use this on 800 machines. It was really, really a botched job. I really recommend not using Unity's paid licenses. The free licenses very rarely go wrong, whereas the paid ones go wrong literally every time I open the system. For example, this, which I see every time I open a project, is Unity's licensing system, just barfing for no reason, just 'cause. So, that little bitterness aside, it's been so long since I've worked on this project that I'm not 100% sure what my next, oops, that's not what I wanted to do, what my next step should be. I was setting up my screen on the other side and it got all screwed up when I locked the cursor there. Let's try that again. So we were working on this debris field and getting this stuff to work, and I can't really remember where I left off. Those side thrusters really look a lot better than I thought they did. When I left them 2 weeks ago, I was like, I'm not actually sure if I like them. Yeah, I like them. They look pretty nice. I might tweak them a little bit, but they have a really nice flow to them. Now, the problem with them as they are is that they are not lit. So if we were to dive down here into the shadows, we're going to see that these are unlit particle effects. So that's something I'm going to have to deal with because I need them to accept shadows, or it'll just look weird. See, they glow in the dark. That's kind of strange. I could half-ass it. I could do something like detect whether the ship is in shadows, and if so, make those, darker or something. Or I could make them like glow, say that they're hot plasma or something. But either way, I'm going to do something about them because it looks really weird as they stand. All right, when we left off, we had just finished creating a variety of components for our ship over here. But we hadn't yet created any components that could be ripped apart in a new fashion. I think that we had done most of the stuff that we needed in terms of having the right parts. So it may be worthwhile to just go ahead and rip them apart this week. I don't really have any strong opinions on that matter. So I guess we'll just go ahead and do that. I'll pop it open in Blender and start to rip them up. So we've got the large ship elements. There they are. And if we unhide everything, you can see that they're all here. So these are not all to scale. This thing here, for example, seems to be a lot bigger than the other parts. In actuality, it's smaller. It just gets scaled up less in Unity. But what we're going to want to do is save these to a new file. Let me go ahead and switch over to Phoenix Write for a second while I save this. Call large ship debris. And we're just going to go ahead and make that like that. Now we do have to have this work with a whole host of other files. We've got these sets of files here. We're going to go ahead and put those in a special quarantine directory just for archival purposes, because we're not going to be using them. But I don't want to delete them just off the bat, you know. So what we're going to be doing when we create debris, all of our debris is built around the idea that it has an identical fail point. No matter what the kind of element it is, the fail point is 10 meters in, or some arbitrary exact identical set of meters in. That means that if we line them up perfectly, if we line them up perfectly like this, then they'll break at the same point, and we'll have a really nice sort of beam weapon effect. On the other hand, if they're not, if they're not lined up, then they're going to have a staggered effect, and we'll have to think about that. But I think that the key here is that if I can line up the 10-meter mark with the base of the other module, then I can have an effect which goes and rips the other module apart and then immediately merges into the next module. You see? I think it should work. I am a little bit sick, so excuse me if you hear any obnoxious noises. I'm trying not to be too obnoxious into the mic, but you know how that goes. So this is our main hab area, and what we're going to do is we're going to carve it across at the 10-meter mark. If we take a look, it's hard to tell where 10 meters is, so what we can do is we can just take our 3D cursor and move it out to 10. You can see there. We've actually built this entire thing with the idea that we'll have a 10-meter cleave, so you can see how that's a nice even line all the way around to the 10-meter mark. And that'll be a nice way for us to do it. But these are not going to be mirrored, so we're going to need to apply the mirror modifier. There we are, because otherwise we would have a rough time of it. Now, for some reason, when I applied the mirror modifier, it dequadded. Why did it do that? I don't want it dequadded. Oh, it's already dequadded. Why is this? Is this dequadded? It's already dequadded. Why? Oh, it's because I used the carving tool. I used the binary operator, and apparently that does not like quads. So they're all tries now, which is a little obnoxious, but whatever. So we've got a couple of different kinds of damage that we can do to these kinds of components. And they're basically split into three categories. There is the category, sorry, I'm trying to get this. For some reason, OBS is refusing to shrink. It's really big, and it won't. That's obnoxious. I guess I'll just put it halfway off screen then. There are three basic categories of things we can do. The first is we can cut in here and then not come out the other side. So it's just like a ding. Another is we can cut across and come out on the other side. So it carves off the front face. And the last thing we can do is cut down and carve out this end so that it's actually gutting all the way down to the base of the object. And those are the three basic kinds of damage we can do. So we're going to go ahead and quickly just duplicate and separate them out and just mock up those three kinds of damage. It's actually surprisingly forgiving in terms of how this is supposed to look, specifically because we are using a system where we automatically generate a lot of the debris that we actually need to fill in this area. But here you can see a basic carved out chunk. And if we wanted to, we could just fill this face in. We're going to want to fill it with a little bit more, what is it, Control F? Yeah, here it is. We're going to want to fill it in with a little bit more, there we are. I don't know how that worked out. Oh, I just had to tick the beauty mark. I see. That's fine. So that's just a very, very simple way to create a face. If we extrude and shrink down, we can create a little bit of an inset, which is valuable for us in terms of creating something that looks a little bit less even. But we're also going to want to make it look less even by literally just making it less even. We'll just grab some of these points, turn on our connected proportional editor, and edit them. We need to be careful not to edit that edge here, just because if we edit that edge, then it'll screw up our connection to the next element in the in the chain of modules. So if we do that, for example, oh, I see, I screwed that up. Somehow we only caught, oh, they're different sizes. I see. Sorry, I'm struggling to figure out the exact size I need to highlight. That's it right there. Now if we drag that back, we should be able to get it. Yeah, that's a little bit better. And we can rotate it. And then we can also rotate it on the x-axis and the y-axis. There we are. And that'll just give us a little bit of unevenness. Now, there are lots of ways to make this work. And there are a couple of ways that work better than others. The problem is that most of the methods that we did learn don't actually work very well for what we're doing right now. Instead, what we're doing is we're using a system where we end up with a bunch of grids coming out of it. And that's what we're going to be doing here. So these square edges are fine because we're just marking them up for grid work. So that's going to be our cut. We need to come up with terminology for the kinds of cuts. Now this is the straight across cut, so we're going to go ahead and call it a cross cut. And that's going to be just a very, very simple way to set these up. Now this one here, what we're going to do is we're going to ding into it, but not go all the way across. And to do that, what we need to remember is that the basics are you must carve off the same face all the way across. So you can't just like go doop doop, because that wouldn't necessarily line up with whatever the guy next to you was. So you have to carve a lot of face off like this. And that's fine. We should be able to do that without too much difficulty. Just carve it, and then we can go and just tweak this until it looks more like what we need it to look like. Oops, too many L's. Try that again. There we are. So that's more or less what we want this to look like. We're going to go ahead and reshape the inside a little bit, but we're going to want to just make sure that this looks like it has a sealed face. So to do that, we're going to just seal here. That's going to be our core face. And then here what we're going to do is we're going to fill in, so I don't get this make edge face logo if I don't hit Control F. Is it Alt F? Alt F. Alt F is fill. That makes more sense. There we are. But you can see how we got this nasty underhang. So we're going to want to make sure that some of this stuff is a little bit cleaner. A little bit clean. And that's, we're going to do that just by doing it like this. There we are. Perfect. And since we have all of these faces, we could gut in here and come up with a really nice interior. And I think we're going to want to do that just because otherwise it's going to feel a little bit fake. So we'll just go and do one axis. We need to turn off our proportional editing. Scale down, push back. Scale down a little bit more on the Z-axis specifically. And then we will extrude and push in and just push in. And then what we'll do is we'll grab these faces, and they will be the other half of this setup. Actually, I'm not actually sure if I can do that. Just in terms of how it's going to fold, it might look wrong. We'll try it. Extrude, scale down. Move in. Extrude back. I guess it's okay. It's okay. It doesn't have to be perfect because we're going to be masking it. So this is going to be, we'll call this an L cut. There we go. And then lastly, we're going to need one where it guts all the way down to the core on the other side. So that's going to just be from here all the way over to here. And probably the easiest way to do that is to tilt. So the only problem is I've forgotten which of these lines is 10. So we're going to have to recenter our core point so that we don't lose track. That's 10 right there. So what we'll do is tilt until the 10 marker. is lined up like this, more or less. But I think I got more than I planned to get, didn't I? Yeah, I did. If I just delete the faces, that'll do. Okay. Okay, so this is a ragged result, and that's because we got tries instead of quads. But that's okay. We can live with a ragged result. So we've got this situation where the whole point is that there is nothing on this side. It gets carved away entirely. So we want to carve away this entire edge so that it can't possibly be mistaken for having contents, you know? Okay, so I actually need to do these separately. So now they can't touch. Now it's ending short of where the connection should be. In order to test that, you can see how this would look when it's lined up. You can see how that's substantially shorter. This is how it would be. And that way, if the next element has a different damage pattern or is a different type, it's not going to end up looking super weird. But we do need to fill all this stuff in, so that's what we'll do. We could try and do a giant beauty fill, but I have a feeling that's not going to work. So we're going to try to do this the old-fashioned way. Oh, I see what's going on there. That's fine. Ooh, that didn't work. Interesting, because it should have worked. I wonder why. That's a strange result. Ooh, I see. It goes all the way up. That's what was wrong. Okay, so we don't need that. All right, so we're going to go ahead and carve this up into manageable chunks. You can see how that did not work. Faces often get very confused as to what's going on, and you can either struggle with that, or you can just go ahead and carve it away until there's something that fills in nicely. There we go. I don't think this is going to work out very well. Oh, it did. That's actually not too bad. All right, well, we'll take it. Let's go ahead and do the injection that we need to do in order to make this have an interior. So extrude, and then scale down, and then extrude in. We're going to need to scale that down, because it's got some bumps on the outside that would look a little bit weird if we didn't. Yeah, that's better. All right, that should do it for that. There we go. So the other thing that we generally want to do is these interiors should be set up to have a dark face in terms of the their coloration. We want them to be pitch black, just because that way any sort of weakness in our setup won't end up being visible. And this is going to be a J-cut, so do. There we go. Let's pop on over to our friend Unity and see if I can get this loaded up. Oh, okay, so what we need to do is create the prefabs for those three variants. And doing that, what we'll do is we'll just grab one of these HAB modules, and we'll just go ahead and duplicate it a couple of times so that it is able to be destroyed. And we'll just switch out the HAB module for the various other variants that we've got, like here's the J-cut. And because it's the same module, there should be a minimum amount of effort required to make it look right. However, the materials are not always stored in the exact same direction, which is an annoying situation, but I can't really do anything about it. So we're just going to have to manually retag these elements. Okay, so it looks like that we lost a material in that mix. There we are. So that's going to be machinery. And then we have just hull, right? Hull. Yeah, like that. So that's going to just be our hab module JCut. Now later on what we'll do is we'll go in and we will make this hab module JCut into something that has a lot of details, like damage elements and so on and so forth. But we don't need to do that at the moment, so we're just going to go ahead and store this as just a little prefab for the sake of having a little prefab. And then we'll duplicate again and repeat the process for the other two kinds of cuts. Hab module JCut. Where are the other hab modules? Did I not name them the right thing? Hab module. Okay, so I must have named their meshes, and that's dumbass. Crosscut. Hab module. What did I call this? Lcut. All right. There's the crosscut. Once again, you can see that the result is I got rid of all of the windows is the thing, so it ended up being so I don't think this is actually, this is supposed to be the interior, and I think I used the wrong one on the other one too. It doesn't matter, I can fix it whenever I need to. It doesn't make the slightest bit of difference. So this is going to be our hab module crosscut. So you notice that one of these things that they don't have is colliders. We're going to deal with the colliders later. For now, it's fine the way it is. Just drop this off in destroyed parts. And then we're going to want one more copy, and this is going to be the Lcut. I probably shouldn't have named one of them Lcut and one of them JCut now that I'm thinking about it. But I was thinking of a lowercase j. Oh well, you know, it doesn't, who cares? Here's our Lcut. And our Lcut has almost the same materials, but it's got them all reversed in weird ways. I really wish that Blender would keep the order of the materials the same, but whatever, it's not that big a deal. All right, there we go. And this is going to be our hab module Lcut. By the way, there is one heck of a windstorm outside. I'm sure you can hear my windows farting and my doors creaking. All right, so now we've got the 3 new variants that we need. We'll just delete those variants from the scene. And we're going to want to create a new script for switching out variants for damaged objects. So in the long run, we're going to need to have something fairly complex to figure out things like neighbors and stuff. But for now, we're just going to go ahead and chain them in the most basic form, just by randomizing it completely. And I'll just hiccup into the mic. We're going to call this a module damager and open that up. Okay, so the module damager is going to have a list of damaged modules. Damage variants is what we'll call them. And then what we're going to want to do is in awake, we're going to want to switch this out for a damaged variant. So in order to damage the variant, we're going to want to pick a random variant, including no variant. So int index equals a random.range 0 damage variance dot length plus 1. If index equals damage variance dot length is greater than or equal to damage variance dot length, then we're going to want to just return, don't do anything. Keep us undamaged. Later on, we're going to have a much more complicated method of doing this, but who cares for now, right? Otherwise, what we're going to want to do is destroy ourselves and replace ourselves with one of the variants. So game object replacement equals game object.instantiate damage variance index. And we're going to want to put that into our parent as well. And then what we'll do is we will just set that up to be in the exact same transform.local position equals transform.local position. And we'll just do that for position, scale, and rotation. Local rotation, local rotation, local scale, local scale. Okay. And then we're going to destroy ourselves. Destroy game object. Now, the only problem with this is that if it's nested inside of other objects, this will end up screwing us up. That's not going to be the case right now, so we'll just put it to do check if we have child objects and make sure they go first. That seems fine. So what we're going to want to do is drop that script into this hab module. Boom. And we'll just put those new damage variants in as the elements that we're going to be able to switch to. There we go. Now we could either, well, let's go ahead and copy this script, and then we'll just paste it in for this guy. There we are. But these three are probably going to be easier to delete and recreate. So that's what we're going to do. Duplicate. We're not on the right snap again. Hold on. Snap settings. I'm not actually sure if that's exactly right, but it's close enough. And we'll go over here and we'll drop this in as a new component as well. And then when we hit play, we should get a result that is all carved up. Boom, 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 boom. So you can see the basic idea is already coming clear here. These objects get damaged and roughed up. Now, this is not the best way to do it. Ideally, what we would do is we would have a blueprint that doesn't actually have any meshes in it until the damage types are decided. Just because otherwise what we end up with is spawning in stuff and then deleting it and spawning in different stuff, which is obviously not the best idea. Yep, seems like this will work. So what we're going to want to do now is come up with a matrix of elements and trace our damage vector along them. So in order to do that, we have to determine which which vectors we are going to be doing. So what we're going to need to do is to have a core ship object handle all of that wrangling. So down here in our ship component scripts, we're going to need a ship damager as well as a module damager. And the ship damager will wrangle all of the module damagers. Come on, wake up. Wrangles all the module damagers. public void damage module, and then we're going to want to have the damage module call be a little bit more aggressive. So right now what we've got is we have two non-mirrorable versions and one that can be mirrored, but we may not want to. So the thing is, we can't actually mirror them, because if we change something with a x scale -1 or y scale -1, then it will screw up our instancing. So what we need to do is duplicate all of these and then flip them and then apply that. And you can see how they all got inverted, which is annoying. And then what we're going to need to do is assign these as inverted. We'll just put a little I at the end to note that they're inverted. There we are. And that's going to be an important element for us to do. So let's go ahead and pull the 3 components that we created back into the scene and create 3 variants that are properly mirrored. That's going to be important for us tracking what's going on with the kinds of damage that we're taking. So if we take a look here, we'll just grab these 3, drop them into the scene. I don't know where they went. Oh, they're tiny. Okay, only one of them came out. How dumb. Okay, well, just drop the others in too, I suppose. And all we need to do to make these things work is to switch out their crosscut for crosscut I, and then change the value here as well. And then here, this is J-cut, switch out for J-cut I, and again, put an I here. Here's L-cut, which we'll switch out for an L-cut I. And again, drop it in. Boom. All right, so now we have 6 variants. The problem is that we don't actually know which variant is which. Over here in the module damager, we've just been doing a damage variance system. What we actually need to do is create a damaged element type so that we can track which kinds of damage these things can do and can take. So I guess that's what we're going to actually need a script for. Just keep adding more scripts. Damaged module. And we're going to have to add this damaged module to all 6 of those, I'm afraid. That's okay, though. It's not too big of a deal. Keeps track of which damage nodes are damaged, so we can create damage chains that make sense. It'll also be able to do other stuff in the distant future, but for now it's just a very simple class for storing which elements are damaged. And we're going to go ahead and call this, is it Y or Z? It's Z in this game world. It's Y in Blender. I think it's better if we call it Y because we're talking about the mesh. So public enum damage module edge type. Intact, damaged, destroyed. Call this a public damage module edge type, Y min, Y max. There we go. And this needs to be system serializable, although I think that the most recent version of Unity does that automatically. I can't remember. Either way, what we need to do here is damage the module, and in order to be able to tell what sort of thing we need to be able to take in constraints. So these intact, damaged, destroyed, we're going to go ahead and put in an any, and that's going to be our default. So damage module edge type y min equals damage module edge type dot any. And y max equals damage module type any. And then what we can do is, and we need to actually pass it a module. And then what we can do is tell the module to do that same thing. So we'll say module, that's not how you spell module, module.damage, and then we'll pass it ymin and ymax. Now obviously we can just go ahead and create that here in our module damager. Right now, for example, damage doesn't actually take any arguments. We're going to want to add in the arguments that we need, which is just these two. There we go. And we're not going to have anything in awake because there's no reason for it. We'll have it all controlled by the ship. But we will have to have a... Oh, it self-destructs, but it only self-destructs between frames. So we're going to have a dealt with call here. Public bool what do you want to call it? Damaged. No, that makes it sound like we can choose whether or not it's going to be damaged. What we're trying to do is processed. That's a good one. So that's fine the way that is. And what we're going to want is a setup where this makes sense, right? Is it all working? What sort of errors are we getting here? Oh, damage is inaccessible. Okay, that's fine. Public damage. There we go. So now what we've got is a setup where the ship damager can call damage module. Of course, right now there are no lists of modules that we have, so we're going to go ahead and get one. Damage module modules, that's not how you spell anything. You can put your fingers on the keyboard and not like randomly off to the side. Get components in children. Damage module, true. And then what we're going to want to actually do here is module damager. What we're going to want to do here is pick at random. So basically what I'm doing is I'm trying to figure out the best way to do this. But this is not a list. I think we want a list. So list module damager modules equals new list module damager. And then what we'll do is we will pass that list here. Because the list can be selected at random and stuff. So while modules count is greater than 0. We're going to pick a random module. So module damager md equals get equals modules random dot range 0 comma modules dot count. We'll go ahead and actually get that value. Int index equals index, and then we'll say modules dot remove md or remove at index. There we are. And then what we'll do is we will just go ahead and process that module, and then we will look for the next module. So to do that, we're going to go ahead and just tell the world to damage this. So damage module md. And here in the module damager, we're going to want to actually remember that we are going to be marked as damaged. Note that this happens between frames, not immediately. All right, so with that in mind, we need to put this into the ship object. Ship damager. We're also going to need to have the module damager do a little bit more work in terms of deciding which variant it wants. This is not going to do it anymore. So this is only going to be free damage. So we're going to go ahead and have like a public void or protected void unbounded or random damage. And then what we'll do is we'll have a protected void use variant int index. There, that should do it. So here we'll just say use variant index. So random damage will only happen if we have ymin and ymax both as any's. And the reason that this needs to be like this is because we need to know which variants we're actually using, which edges we're actually taking. Well, I guess what we want to do is return a damage variant. So these game objects are not game objects. They're going to be damage modules. Damaged modules. We're going to want to put the damaged module objects to work here in our destroyed parts. All of these need to have a damaged module added to them. Boom. And that should have done it for all of them. Yeah, good. And then what we'll do is we'll switch this out for damaged module variants. And then here, these will be damage modules, damaged module, damaged module. And the reason that we're going to want to have those as damaged modules is because we can return the damaged module as an object. And that will give us all the clues we need as to what sort of variant we're looking for. Damaged module. So here we're going to go ahead and right now we don't have any logic here, so we're just going to add some. We'll just return if ymin equals any and ymax equals any, return random damage. Otherwise, we're going to need to create a list of potential variants that fit our requirements. So list damaged module valid equals new list damaged module, and we'll just go through all of our variants for each damage variant. Oh, actually, if there's another option here. If they're both none, then we obviously have to do a null. So if we're not damaged, then we're not damaged. And if we don't care what kind of damage, then we're going to do it randomly. But otherwise, we've got to find variations that actually work. Damaged module in damage variants. And then we're going to want to compare ymin and ymax. So if ymin does not equal any, then we're going to want to check and see what sort, if that ymin is going to match. So if ymin dot, if module dot ymin does not equal ymin, continue. Invalid. And then we'll do the same for ymax. So valid equals, no, not valid equals, yeah, valid.add damaged module. Yeah, module. So right down here we say use variant index. That's actually something we're not going to want to do. We're going to want to have it actually pass in a damaged variant here. Damaged module. And that's because we're not using damage variants here. We're using the valid list instead. Got really dark in my room all of a sudden. So we've got this set up so that we've got, oh, I didn't zoom in on the code. All 0 of you couldn't have seen it very well. Either way, we've got a list of the possibilities, and we're just going to go ahead and grab an index for that. Int index equals random.range 0, comma valid.length count, rather. I guess the first thing we're going to want to do is make sure we've got some. If valid.count equals 0, debug.log warning, no valid variance for damage on name when ymin is symin and ymax is plus ymax. Return null. Otherwise, we will just go ahead and use the one specific thing. Return use variant valid index. There we go. That should now work for everybody, but we don't have this connected yet. Our ship damager doesn't actually keep track of what's going on. So here when we get this module damage, you can see how we can take in a ymin and a ymax. What we're going to want to do is damage the module, and then we're going to want to look for modules which are adjacent. So damaged module variant equals, that's not how you spell variant. So when we get here, we're going to want to make sure that that variant isn't null. If not variant intact, then we will want to move to the next. Actually, it doesn't even matter. We'll pull the ymin and ymax off of them. So if there's no variant, then the ymin and ymax are both going to be intact. Else they're going to equal the damage. So ymin equals variant.ymin and ymax equals variant.ymax. There you go. So that is going to be a fairly basic way to set these up so that we have the correct ymin and ymax for all of these objects. But what we need to do now is actually go and look for the next module in the chain in both directions. So in order to do that, we're going to go ahead and get the y-axis from our module, module.transform.up. I'm pretty sure this is correct, but let's go ahead and debug.log it. Y-axis is, no, that's not how you do it. Y-axis. That's just for debug's sake. We'll delete that in a minute. But once we've got the direction which we're searching for, what we can do is go through all of the other variants and try and find out if any of them are in the right position to be neighbors. And that means that this is going to have to be something that is global. Not global, but, you know, class-wide, non-local. Otherwise, we wouldn't be able to search. So for each module, module damager, next in modules, if, we shouldn't be doing this inside of a for each loop though, should we? Because if we do it inside of a for each loop, then if we edit the for each loop, we'll screw it up. So we'll do it as a loop. For int a equals 0, a is less than modules.count, a++, and then we'll just say module damager neighbor equals modules a, and then that's not how you spell neighbor. It's not even close. There we are. So when we have this, what we're going to want to do is get the delta. So vector3 delta equals neighbor dot transform dot position minus our transform dot position. But I say that, except for that is the global position of them, and if they are scaled, that global position may not be exactly equal to what they should be. So what we need to do in addition is to divide that by our scale factor. So delta divided by equals module.transform.scale. Local scale dot, doesn't matter, anything, y. So in theory, that should get us a delta that is going to be relative to the object. The problem is that they're different widths as well, now that I'm thinking about it. Well, let's go ahead and just assume that close enough is good enough, and later on we'll try and figure out a better way to do it, maybe with bounding boxes or something. So if float alignment equals, well, first let's just say if delta.magnitude, sorry, I'm trying to think about the easiest way to do this, and the easiest way to do it might not be the way I'm doing it right now, but that's okay. Float dot equals delta dot dot, or vector 3 dot dot, delta and y-axis. If dot is less than 1, so I'm not actually sure. Let's go ahead and just debug this. Debug.log delta is. Delta dot is, and then dot. Between, and then neighbor.transform dot position, and module.transform dot position. Now that's not going to actually do anything. So all we're doing right now is we're going through and we're damaging it all as any. So we should get the exact same result. Well, you know, random values aside. We shouldn't get a good chain or anything yet because we haven't actually finished programming it. Return random damage. You done yet? Finally. Okay. So all of these now should get damaged when we hit play, but they're all going to be randomly damaged because we haven't hooked up the actual checking yet. They didn't even get randomly damaged. I'm not sure why they... Oh, I forgot to restore the... Sorry, there's a list that I forgot to build here. I gotta put these destroyed parts back in. Because I changed the array type from a game object to a damaged module object. We're going to want to copy this. And then we can go here and we can just select these and paste component values. There we go. Nice and easy. Save that. Now we'll hit play and it should work. I don't see any errors. Yep, look. So we've got a whole bunch of damaged components, and for some reason in this case it really preferred the L cut, which is, you know, fine by me, but it won't be able to do that over and over and over. What we really need this to do is to have this thing, this accidental lineup. That's going to be the new normal. We're going to want that L shape every single time, except for it's not always going to be just the mirror image of the same objects over and over and over. So let's take a look at what it actually said when we look at the, here it is. So if we take a look, we've got some values that are extremely large. So we're trying to find the delta between some extraordinarily large values. I don't think we're doing our math right, even to begin with here. So if we take a look at the ship damager, the y-axis is module.transform.up, which is fine. What we want to do is check and see whether or not there is something either directly along or directly away from that axis. But what we have been led to do is get, okay, so these very, very large values are correct, but 300 seems to be like the good value, and anything over that is probably someone else. So we'll go ahead and set that up here. If dot is greater than, is greater than 50, and dot is less than 400, magic numbers, then what we're going to want to do is set up this as a neighbor in one direction. So we'll just go ahead and say damage vit module, and we will pass it the neighbor, which is neighbor. We're going to pass it the y min of our y max, and then we're going to pass it an any. But we're going to want to remove it from the list as well. So modules.remove at a, and then we're going to want to do a minus minus. And then we're going to want to continue there. If it's the other direction, then we want to do it the other way. So we'll just copy paste. If dot is less than -50 and dot is greater, negative 400. Same thing, but with any and y min. All right, that might work. Shall we try it? Do I have any damage? Nope, seems to be fine. Let's go ahead and hit play and see what happens. Oh, I should have probably actually created something that feeds that back. So there's definitely something going on here, but it's not quite working. So we're going to go ahead and put in some values here. Debug.log name or module.name plus neighbor is, and then that's going to be neighbor.name. We're going to call this the plus neighbor. And then down here, we're going to call it the minus neighbor. That way we'll actually be able to have some sort of indication of what's going on. All right. So if we take a look at what we've got here, hab neighbor, hab module 1's neighbor is hab module. So if we take a look at that, this is hab module 1, and this is hab module, so that makes sense. And they do match. This one also matches, but I think I screwed up the deleting on some of this because this face element there sticking out is actually illegal. We're just going to go ahead and go in and delete that one little element. Wait, I think that whole set of faces is illegal. God damn it, I ruined it. All right, well, we'll just go in and edit these so that their faces are set up correctly, because these are all illegal faces. No, it did not like that, did it? Let's go ahead and do a little bit of sealing to help it figure out what's going on. No, it's barfing. It does not know what's going on. It's so confused. All right, well, if we pull this line back and down, we'll at least have something vaguely good. Grab this, merge. All right, good enough. And then we'll go ahead and delete this guy, copy his name, and then delete him. And then we'll just duplicate this guy. Scale y -1, apply scale, flip, paste the name. There we are. That should clean up the jagged edge that doesn't make any sense here, which is fine. But unfortunately, it looks like our system isn't really working, because what should have happened over here is this should have had a J-cut. So we're going to want to be a little bit more specific as to how we do this. If we take a look, it does line up. Hab module, hab module 1, hab module 2, hab module 3. Those are all in a row. But if you take a look here, we never found hab module 3. It only did hab modules 0 and 1. And it started with this one, and it spread to here, and then this guy never got called. Or at least it never got called as a neighbor. It might be because of the deltas. It might be that it didn't get caught by the delta. Let's go ahead and have an else, and then at the end we'll have another else. Else debug.log module.name plus module.name is not neighbors with neighbor.name. That should give us a full readout on absolutely everything that goes on, and that should be good enough for figuring out where our bug is. All right, so we've actually got an even worse situation this time. So it says here that we are looking from Hab module, which is right here. Hab module 4 is over here. So Hab module 3, oh wait, 0, 1, 2, okay, so none of those are correct. Hab module 4 is this guy. It doesn't have any neighbors. Hab module 1 is negative neighbor. So here we can see that Hab module 1, which is this guy, found a negative neighbor of Hab module, which is this guy. In theory, that's correct. And then it set over here and started to look for more neighbors. And it couldn't find any neighbors because we don't have any other neighbors. This is on the end of the line. Then it said, okay, well, Hab module 1 is not neighbors with Hab module 5, which is funny because Hab module 5 should have been processed by then. Hab module 1 is plus neighbors with Hab module 2. Right there, that's correct. Hab module 2 is not neighbors with 5. Hab module 2 is plus neighbors with Hab module 3, which is correct. So there's no errors here, except for the small fact that it appears to be not actually bothering to take into consideration our concerns for Y min and Y max. It might be that I have them inside out. Let's go ahead and just take a quick little look here. Maybe I've got them just going the wrong direction. So I don't see how. Hab module is plus neighbors with Hab module 1. So yeah, okay. It looks like what's going on here is I am doing them backwards. So we're just going to go ahead and invert them, which is easy enough. We'll just do this as a Y min, a Y max, comma any, and then this one will be Y min. And I think that's the issue. Let's find out. Oh, I didn't wait long enough. Darn it. Well, technically that is correct, except I'm not so confident about this crease here. Let's go ahead and create something that's a little bit more obvious, just so that we can really get some good testing done. I'll drag all of these out, and then we'll just create some more, delete these two. And then if we duplicate this, we should get Hab module 4. Yeah, so that way we can just keep testing. So what I'm concerned about, oh, you know why this isn't working? I forgot to make it work. That's why it's not working. Oh, I'm an idiot. I really, really hate being this dumb. It is really impressively dumb. So I was going on and on and on about trying to get these things to work, and I forgot that I still had all of these modules set up as any, which is obviously not going to help. So this, for example, these crosscut modules are both going to be damaged and damaged. The JCut module is going to be damaged and destroyed, but I don't know which way is which. I can always flip them later, I suppose. And the LCut is going to be damaged and intact, and then intact and damaged. There we go. So that should be better. Now the only question is, do I have to flip them back and stuff like that? Because I think that these are now reversed again. Any damage to our code base? Nope, seems to be working. All right. So now if I hit play, Oh, that's more like it. So this isn't yet perfect. Let's see. What we started with is Hab Module 1, which is this guy. And it looks like... I can't even tell whether they're backwards or not. See, that one actually worked. But why didn't it work the first time? Okay, what I'm getting now is a lot of just arbitrary damage markers. Let's go ahead and put down some indicators here. Debug. Debug.log. Random damage 2, and then we'll give it the module damager.name. And then down here, we're going to go ahead and delete this. And save this so that we don't have any problems. And let's go ahead and get some more information on what's going on here. So random damage to Hab Module 3, which is this guy. Well, that's all correct. It looks dumb, but it's correct. All right, so this is not correct. So this is errored out. Random damage to Hab Module 2, which is this guy. Hab Module 2 is neighbors with Hab Module 1. That one worked. And then it says Hab Module 1. So hold on, let's delete this, because that's clearly working. So I'm trying to figure out the pattern that's causing these to get damaged, and it looks like it might be that the positive neighbor's all screwed up, but the negative neighbor works fine. Not really sure. Hold on here. So Hab Module 5, 1, 2, 3, 4, 5. Let's go ahead and mark up which elements are currently being called here. Debug.log module.name plus ymin plus ymax. Now that's pretty close to correct. We still have an invalid connection though. So random damage to Hab Module 4, 1, 2, 3, 4. As usual, the plus side is the side that didn't work. But it looks like it worked everywhere else. That's interesting. Hab Module 4, any. Hab Module 3, any and intact. That's correct. Hab Module 3 does down to Hab Module 2, any and damage. That's correct. Hab Module 2 down to Hab Module 1, any and destroyed. That's correct. This is any damaged. That's correct. Any. Hab Module 6, huh? So it didn't catch on that these were even in the queue. So for some reason, the positive value isn't actually working. So that means that we are not ever progressing on the other direction. Only the down axis is working. Yeah, those are all minus neighbors, no plus neighbors. Let's try and figure out what the plus neighbor problem is, because it should work. Hab Module 5, 1, 2, 3, 4, 5. Okay, you see, again, there's the damage. So delta dot, hold on, let me put the name in there instead of the... All right, so once again, it's 5. That's interesting. So we're looking at Hab Module 6 and Hab Module 5 here. here we are. Hab module, hab module. Huh, so hab module 5 never checks to see whether or not... This should only go to the next element of the loop. It shouldn't stop it from... Wait. Oh, I know what the problem is. So the problem is that this is actually going off into another element, which is reducing the module count further. So we're actually removing all of the modules. And so for this to work, we're going to have to say that A equals 0 or A equals -1 or something. Because otherwise, it's not going to end up working out for us. Another option is we could parse through, first looking for all the negative and then looking for the positive as separate objects, which is probably a little bit better. No, this is okay. It's fine. Either way is fine. We can't guarantee that the list is going to be... Oh, so see, look, that actually worked. It's dumb, but it worked. The problem is that the damaged walls are fairly boring. And the reason that they are so common is because we've put both of the kinds of damaged walls, you know, both of the crosscuts in. So they are twice as likely as any other kind of module. The easiest way to fix that is to just remove one of those crosscuts. So we'll select all these. And we will just, one of these crosscuts, can we delete an element? Yeah. There we go. Well, that's not ideal, but it works. To be honest, I don't mind if there's a lot of intact ones, that's fine. But here, I found a bug. So this is definitely one where it's not working. So what happened? Random damage to Hab module 2. So we take a look at Hab module 2. And Hab module, it's too far away. This is Hab module 1, found the 1. And then this should end up being, yep, that's correct. So that all works. And then boom, 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 boom. Here we are. So then we go over to delta 3, which is this guy. It goes damaged any, that's correct. And then delta 3 starts looking, and it says, okay, well, my neighbor is module 4, which is this guy. And I think that it didn't work. If we take a look, module 4 is supposed to be damaged any, but instead it's any damaged. So I think that I've got these backwards. Yeah, okay. So my L cuts are backwards. So we'll just go in here and swap them. Oh, it wasn't even that they were backwards. They hadn't any. That was probably the problem. So they're probably correct. So hold on. L cut, this is the initial one. So this is going to be intact and damaged, and this one's going to be damaged and intact. The problem was I left it as any rather than as intact. So it was just randomly making things up. Like me. There we are. That's more like what I expect to see. Now, obviously, there is no guarantee that the damage is going to look good. I don't really care about that at this stage. Ah, there we are. This is the sort of thing I'm looking to get. Now, right now, this looks pretty basic, right? But that's because all of these are not currently kitted up with debris. So once we add in debris, we will have quite a dense field in here. That will be fun to explore, and it'll like radiate out like this. It'll be really cool. But we're not going to do that today. I'm still feeling under the weather, and I can feel my my various medicines wearing off. So I'm going to stop here for the day. I'm going to say that this was a successful attempt to get back into the swing of things. I'm just going to move these into the ship and take a beauty shot. And then that will be it for today. If you have any questions or whatever, feel free to let me know. Was there something in there? No, okay. Let's hit play. Nope. I need to get one that actually looks interesting, you know? Ah, better. Sorry, I'm trying to figure out what a good angle for this would be. I think I need to back up a little bit. Oh, I have a free cam. That's right. I can actually change my camera angle. I forgot I could do that. All right. Thank you for your time. I'll see you next week. Feel free to shoot me any questions or whatever. Bye.